Okay guys, I'm just going to go through some limit problems from your EAS calculus workbook. So I believe these problems were found on your external assessment book on page 78. So I did an introduction to limits at the end of last week. I'm just going to go through 6 of those today. So the first one I'm going to look at is the limit. What happens as we get closer to 4 in this function here? Now, you'll notice that we can actually divide the top and bottom by x minus 4. So we can divide by x minus 4, but notice that if x was 4 itself, this function would be undefined. So f of 4 is undefined. So at 4, this function just can't be defined. You can't divide by 4. So we can still do this division, but we have to note that down. Now, what happens as I get closer to 4 now? Well, I've only got x plus 5. So the limit as x goes to 4 of x plus 5 is 9. Now, if we were going to look at this graph, it's actually a straight line graph. It would look something like this. So we're on the x and y axes. We're looking at, it basically looks like the line x plus 5. So it looks like this, but it would have a hole in it. So at 4, it's undefined. But as we get closer and closer to 4, we will get closer and closer to 9. I know I've done this really roughly, but as we get closer to 4, we get closer to 9. But at that point, it's actually not defined. It's got a gap. So it's a discontinuous. There's a discontinuity in there. Okay. So what's going to happen as the limit of this goes to 0? Well, again, we can divide by x, top and bottom, but then we have to say that f of 0 is undefined. Okay, at 0, we have 0 divided by 0, and that can't be defined, can it? We can't divide by 0. So what happens to x plus 1 as we get closer to 0? The limit as x goes to 0 of x plus 1 is 1. And again, it's a straight line with a gap in it. So it's undefined at 0, but if you got closer to that value, you would get closer to 1. Sorry, that would be not there, that would be through that there. It's undefined on the y-axis, but you would get closer to 1. This is an interesting one to look at. The limit as x gets larger and larger. So this is a good one to look at on a calculator. What happens, because you can't divide by infinity, that would be ridiculous, but what we can do is divide by, if I divide by 1, for instance, it's 1. If I divide by 10, I get 0.1. 100. Notice what's happening to my number. Alright, now we're in scientific notation, but that number is getting smaller and smaller. So the limit as x goes to infinity of 1 over x is equal to 0. You get closer and closer to 0 the closer x gets to infinity. Now remember, it doesn't matter what happens when you get to that number. It's only what is happening as you tend to get closer to it. It's not about what happens at infinity, it's where is this going if you were to go on to infinity. And that's a good example because you can't ever actually get to infinity, but you can get very close. So now we're just taking these concepts and we're just mixing them with your year 11, year 12 algebra skills. So on this one, notice we're just going to go x to the 4. What's the limit as x gets closer to 4 of this function? Well, that's the difference of 2 squares on the top. And that is x minus 4 on the bottom. So x can't be 4 because then you divide by 4. So f of 4 is undefined. So we can cancel that and then we'd get closer to 8. So the limit as x goes to 4 of this function, let's go x squared minus 16 over x minus 4 is equal to 8. So if we were to get a piece of paper, if we were to plot this up, then there's a hole at when x is 4. So at 4, there is some hole. So we've got some hole there. It's undefined. But as we got closer and closer to that number, we would get closer and closer to 8. And that's what we've figured out there. So at 4, it's undefined. But once we've done that division and made that observation, then we can say it's going to 8, because that would be left with 8 as we got closer to 4. So hopefully this is starting to make a bit of sense. So it's not really any harder now. It's just got to factorize the top and bottom. So the limit as x goes to 3, we'll factorize the top of this, x plus 3, x minus 2, factorize this one, x plus 3, x plus 2 now. And notice that these x plus 3's can cancel. So is that meant to be 3? Maybe that's meant to be -3. I think that, yeah, that's meant to be -3. So notice, if that was just positive 3, just chuck positive 3 top and bottom, and that will give you your actual limit. But our limit here is x can't be -3. So f of -3 is undefined, and the limit as x tends towards -3, and then we just put -3 in, so that's going to be -3 take away 2, that's going to be -5 over -3 plus 2, -1, so that equals 5, and I'm just going to put f of x. The limit as x goes to -3 of the function equals 5. So even though it's not defined at -3, it still has a limit. Okay, so have a look at this one. It's x plus h squared minus x squared. And what happens is this goes to zeros. H goes to 0. Well, you'd think that it would be undefined. But let's have a look at what happens when we rearrange and manipulate this. So we'll expand the top. X squared plus 2xh plus h squared minus x squared all over h. So I've just expanded that bracket. My x squareds cancel. I've got 2xh plus h squared all over h. And notice I can cancel an h out of everything in the top with something in the bottom. We now have 2x plus h. So the limit, it shouldn't be equals. It's just the limit as h goes to 0 of 2x plus h equals 2x. Notice that as h goes to 0, this thing that goes away, and we're left with just 2x, which is quite interesting. Okay, so something that might initially look like it's just going to be undefined when h is 0 is in fact actually defined, and that's an example of one that's a bit more pure algebraic, and that is actually something called differentiation by first principles, which is what we're going to look at in a couple periods time actually. So hopefully that's helped some of you get through that page of working. Let me know if anything is going amiss there.